Welcome back, everyone. Today we're going to continue our work with statistics and data displays. Specifically today we're going to look at making a histogram. So we're going to make a graph that looks something like this. Before we talk about histograms, we got to talk about frequency tables. Frequency tables are just a tool that's used to organize the information for the histogram that we eventually want to make. So you can see this person was given a data set right here, and what they did was they created a table with 3 columns. You don't always have to do 3 columns, but you'll see why in a moment that you may want to. The tough part is actually figuring out this part. What are your range of values going to be? But then it's just a matter of counting and then summing up the number of tallies that you had as you went through your data list. In the first column is a range of values on each row. So here, if a number occurs between 0 and 9, I'm going to put a tally here. And as I read through here, there's 1, 2, 3, 4, 5, 6, 7 numbers between 0 and 9. Now, if this data was randomized, it would be harder to see how many numbers between 0 and 9 there were in the data set, and it's often easier just to go one at a time. So I see a 1, I make a tally. I see a 6, I make a tally, and so on. So the third column is just for the sake of representing the tallies as a number rather than a set of tallies, because sometimes these data sets can get very large and your tallies can get very messy. So we just want to represent it as a number once we're done with our tallying. And once we have the frequency table made, then we can move on towards our histogram. So a histogram looks like this. It's basically a bar graph with no gap between the bars. Y-axis is always frequency, so we're graphing frequency versus these little bins that hold a range of values. And things that are in common to all histograms, the y-axis is always going to be measured in frequency, or sometimes it's measured in percent, but it's basically percent is the same thing as a frequency. How often does something occur? Then we're going to have a title and labels, so we got title and labels everywhere. There's no gap between the bins. That's what distinguishes a histogram and a bar graph. A bar graph, sometimes you're allowed to have a gap between the bars. A histogram, you're not. Although you'll see that this rule is broken in real life all the time. The second thing that's very important is that all of the bins have to have the same number of items in there. So you can see that this bin, if we were talking about attempts, has exactly 10 items in it. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's 10 items, even though if you did the subtraction, it would be 9 items. But there are 10 items here, there are 10 items here, there are 10 items here, and so on. So that's basically the only rule that can't be broken at any point, but all the other ones you'll see in real life that there might be gaps. This might be a percent, and they're actually really bad in real life about doing a title or axis label because they'll have a supporting article that describes what the graph is showing. And as we look to make our own histogram, let's take a look at a process that will allow us to make any histogram we want. This is a generic process. You can do it any way that you want, but here's my suggestion. The first bit is actually the toughest. We have to choose how big the bins are. So the couple rules is that the bins have to have no gaps between, and they must be of the same size. And that's a little daunting when you look at a data set because you have a whole bunch of numbers and you don't necessarily know how big each bin should be. So a rule of thumb, a way to do it is that you want to get 5 to 7 bins. So if you take your range of your data, your biggest number minus your smallest number, divide that by 5, and then round that down to a number that's easy to count by. If you take your number and you divide it by 5 and you get like 21.6 or something ugly like that, just round it all the way down to 20 because 20s are easy to count by. If you do that process, you'll roughly get 5 to 7 bins, and at least they will all be of the correct, or they will all be of the same size. And once we have those bin sizes, we're going to start making our frequency table. So we're going to put the bins in our frequency table. And once we have our frequency table, then we're going to set up a graph just like this. We're going to draw the axes and we're going to draw these bars at the appropriate frequency. So let's do one. Here's our first one. This is a random sampling of the number of M&Ms in a box of trail mix. So here's our data. It is randomized. It is not in order. You may choose to put it in order. You don't have to. But as we survey this data, what we want to do is we want to first try to figure out what our intervals are going to be. How big are our bins going to be? So I go find the biggest number here, 119 right there. Go find the smallest number here, 31. I'm going to subtract those so I get my range. And then I'm going to divide that number by 5 to get me roughly, we're shooting for 5 to 7 bins. So if we do that, we get 17.6. Now that's not a nice number to count by. Even if I rounded it down to 17, that's not a nice number to count by. So I'm actually going to round this all the way down to 15. But if I count by 15s, I also don't want to start at like 31, my minimum value. Let's just start at 30 and count up by 15s. So I'm going to write in my first interval to be 30 to 44. And you might notice that that's not actually, if you did subtraction there, it's not 15. Well, this is actually 44.9999999, everything up to 45. And if you actually count the number of integers in this set, 30, 31, 32, if you count them all, there are 15 numbers in that set. So the way that I do this when I count by 15s, I just take my first number and I add 15 to it and I write them all down there. And I take this number and I add 15 to it and I write them all down right there. So there are my intervals. Looking at them, it looks like I got 1, 2, 3, 4, 5, 6, really 6, because the seventh one is going to be empty, but I have 6, so I'm happy. So now I'm just going to go through my data and count how many data values fall between 30 and 44. So I go across here, there's one right there, so I make a little tally. That one is in the next group, okay, so I'm not going to count that one. There's 32, that one counts. There's 31, that one counts. 39, 49 is too big, 59 is too big. There's a 33, so I'd count that. A total of 5 in that category, and I just do that for each category. So I do my tallies. If you wanted to write it out as a number with a third column, just label it frequency, you can. At this point, I think I'm just going to label my axes so I know what I'm plotting. So I'm going to say number of M&Ms in a box, put my frequency, as always, on the left-hand side, and the M&M count goes across the bottom. Then I just go box by box, so I need to go 5 frequencies high, frequency count high. So I'm going to draw a box right there that starts at 30 and goes to 44.9. Okay, so we're going to draw a box right there. So we're going to go up to a frequency of 5 over, so that the width of this box is 15 units. Just keep doing that. Next one is 5. The next one is 6, so you'll see it bump up a little bit. Next one is 2, and the next one is 1, and the final box is 3 units high. Now notice that there's no gaps. Each one is 15 units wide for consistency, and I got a title and I got an axis label everywhere. So I think that's done. Looking at this graph versus this data, we can see that a lot of boxes had between 30 and 75 M&Ms in them, and then it trailed off pretty strongly, except for we did have some boxes with a lot of extra M&Ms in it. So just by looking at this picture, we can come up with some observations and some conclusions about the data. Speaking of observations and conclusions that can be made about data, well, we can ask a whole bunch of questions based on some pretty complicated looking histograms. So this is actually a double histogram that's overlaid one on top of another. The purple pinkish color is the incomes of women working at a particular company. And then right here is in the green is the number of men whose salary is at a particular level at this company as well. And they are overlaid so you can see how many of each salary. This is a frequency count, so there's a lot of people working at this company, 50,000 employees, but you can see who makes how much money. And so from this we can see, well, there's a distinguishment between women's salaries and men's salaries. You can see that the men's salaries are shifted up the scale a little bit, meaning that men typically earn more in this company than women do. And you can see that trend a little bit more down here too. See all this green popping up? This is a higher frequency of higher paid male workers. So we can come up with some conclusions just by looking at this graph. What's the most common income for a male? We'd go to the clump right here. That'd be somewhere around 30,000, 35,000. What's the most common income for a female? We'd go to this clump right here and we drop all the way down to 20,000. So there's a big disparity there. How many people have incomes over 140,000? So we'd be counting men and female. So let's say 140,000 is right here. We'd figure out how high each one of these bars is and add them up. So, let's say we got about 5,000, 6,000 people right there. Let's, roughly speaking, that would probably be about 20,000 people, but you'd go out, add up the heights of every single one of these bars to figure out what that number. How many fewer women earn more than 140? So we distinguish between male and female there. So we'd figure out how many males earn that much, and we figure out how many females just by adding up the heights of the bars again and then subtract those two. And then we can make more meaningful conclusions or ask more meaningful questions. How can we fix the disparity in income between genders? Well, we can say, well, there's the problem is pretty much throughout the entire range of salaries, but most people land in here. So maybe you want to focus at the lower income bracket rather than the upper income bracket. Or maybe you see it just the opposite. You say you don't want your highest paid people to be male. And have that be a position of leadership. So maybe that will trickle down. That's your choice when you look at a graph like this, and you can come to your own conclusion, but you can use the graph to make an informed decision either way. Next graph I want to look at is one from Chipotle's data. Basically, this shows how many calories are in a given meal and how frequently that number of calories occurs. So we can look at how many calories does a typical meal have. We look for the highest grouping. And they even summarize the data right here. Most burritos have about 900 to 1,000 calories, and that seems to be true based on this histogram. Although there is a lot of meals happening right in here that are over that 1,000 calories. What percent are over 1,000? Well, then we'd have to find the 1,000 one, and then we're going to add up the heights of every single one of these, which would be a very tedious task, but it could be done. Are Chipotle burritos healthy? Well, 1,000, if the median or the mean or the normal or the mode is about 900 to 1,000, I would say that's a pretty big meal, pretty calorie dense, and you don't want to eat that every day like that. How can you make healthy decisions? Well, they were even nice enough to say, hey, this small bump here is from add-ons, so avoid the guacamole, avoid the extra chips, the soda, whatever, and maybe you can reduce the calorie count just a little bit. That's all we have for the day. You should be able to make a histogram, and you should be able to interpret a histogram. I'll see you next time.